Welcome to Access Control, a podcast providing practical security advice for startups, advice from people who've been there. Each episode will interview a leader in their field and list best practices and practical tips for securing your org. For today's episode, I'll be talking to Julien Fayon, author of Securing DevOps and a security engineer at Google Cloud. Julien was previously on the Firefox operations security team, where he built and grew a remote team of DevSecOps teams from the ground up. I picked up Julien's book a year ago and it's loaded with practical tips for bringing security into DevOps, making Julien the ideal guest for today's episode. This episode isn't sponsored by Julien or Manning Press, but I'd highly recommend picking up a copy. We'll have a link to the book in the show notes below. Hi Julien, thanks for joining us today.
Hi Ben, thanks for having me.
So to kick it off, you have a background in cryptography and information security management. Can you tell me how you've leveraged this expertise as a practitioner of DevOps?
Yeah, this is definitely an area where I spent a lot of time at the beginning of my career. I would definitely not call myself a cryptographer. What I learned studying cryptography is that I didn't know nearly enough to earn that title and learn a lot of humility in the process. What I've discovered very early on is that the approach we had to information security in the 2000s and the early 2010 just wasn't adapted to modern web services environment that were actively adopting the cloud. And there was a lot of pushback from security teams to remain in the on-premise environment and continue to use the old controls that we had in place and built over the 20 years prior. Mm-hmm. And engineering team, SRE teams and developers were pushing the other direction, saying we need the scalability, we need the flexibility and the agility of DevOps, and the security team needs to adapt and needs to reinvent its set of security controls for that new environment. And as a security engineer, but also someone who spent a lot of time in systems and operations, I had a lot of empathy for those SRE teams, and I was very interested in actually building tools and techniques that would work in cloud environments. And that's how I got into the world of DevOps and tried to build security around it.
DevSecOps has been sort of a movement of the last 5 to 8 years, I guess. That's sort of combination of both as the DevOps has matured and security has matured.
That's right.
And then you start your book with applying layers of security into the DevOps pipeline. And this has tons of great advice for protecting a web application and securing the delivery pipeline. For startups, which part do you think is important that they should build, buy for their DevOps pipeline?
I think it's important to start with the smallest attack surface possible for a startup, right? Really focused on your product as much as you can and leave those complex infrastructure security, cloud security problems for later on. So my advice is always, as you start, really leverage existing products, leverage code hosting solutions, CI/CD solution hosting solutions that will be secure by default, and generally easier to operate than something that will be running on-premise and will require a full team to manage. Now, of course, depending on what the startup is building, they may have requirements that force them in a certain direction. But generally speaking, for the first 2 or 3 years of a startup, there will not be a person, and let alone a team, dedicated to security. And therefore, minimizing the risks and the attack surface is critical.
Yeah, so you're much better going with a Circle CI as opposed to a self-hosted Jenkins, if there isn't the requirement or someone to even manage and maintain it.
That's right. That would be my recommendation. Now, again, some teams have chosen the self-hosted Jenkins route and done very, very well. But they usually have a specific use case for that solution. And if you can leverage, a vendor first, it's often a better approach.
And so as companies sort of start, you might start with like a fresh AWS account, you have access to everything, and then you slowly reduce, the privilege that developers or teams can get access. Do you have any tips for providing sort of roles of least privilege without limiting access to resources?
Yeah, I think a lot of teams have gone the route of giving everybody access to everything at first because that was a business need. and the company was small enough that it was acceptable. And then obviously that doesn't scale to a point where there are too many people in the team and that they need to start segmenting permissions. And I think it is, in fact, a fine process to go through. I think it's fine to start from a fairly open environment when there aren't that many people around, and security exposure is fairly limited. And I also think it's very healthy to re-architect after, let's say, a year or 2 years, and maybe create a new AWS account or a new cloud account, whatever, GCP, Azure, and migrate the critical components over to that new environment with better security controls. It is very unlikely that the first version of a software stack will be viable long term, right?
Yeah.
So getting into the cloud services and cloud security business, knowing that re-architecting regularly will be needed, is, I think, very healthy. Now, I've seen teams take that to the extreme. At Mozilla, at some point, we took it to the extreme of having one AWS account per environment per application, which turns into a lot of AWS accounts. And there's a lot of tooling overhead with this, being able to manage user accounts and permissions across a large set of AWS accounts is not easy. It is something that a larger organization will probably have to do at some point. We see the same problem in GCP organization as well, but it's not something that I would design for from the get-go, I would say.
Yeah, it's kind of, you're designing your product market fit first, and then once you got that fit, you should start thinking about what the security concerns and what are the risks for your business, and then build it into the next version as you sort of migrate.
That's right. Keep it simple at first and then gradually add complexity.
Yeah. Another topic that jumped out to me, we kind of run into, is always bootstrapping trust, and the idea of you starting with a new system and you need to get trust across all of these different services. Do you have any tips for bootstrapping trust and making sure that secrets don't get leaked across systems? People who, like, are there any services out there that can help people sort of bootstrap trust without ending out with some JSON secrets, like on their local machine, for example?
Right. I think it's definitely one of the most critical issue we observe in cloud environments today is leaking credentials, leaking secrets that give attackers access to identities or accounts in the cloud and can be misused to break into services or abuse resources and incur, the typical example of somebody get access to access credentials and they started mining Bitcoin in the AWS account, and suddenly you have a $100,000 bill you have to pay. I think a lot of teams have tried over the years to adopt password managers and secrets managers of various degrees of usability. And in many cases, those tools are just not good enough. And they're so clunky and difficult to use that at some point the secrets will end up in the wrong place. And they will end up leaking in a patch, on GitHub, and that's the typical place, or a paste bin, or a log entry posted somewhere, or something like this. To me, the biggest problem here, and we spent a lot of time, years ago, I wrote a tool called SOPs, which is effectively an editor for YAML files that will encrypt all of the values so that we could store secrets in configuration files completely encrypted. It will decrypt with KMS, et cetera, et cetera. Nowadays, you can do that using capabilities that are already built in the cloud. You can use that, HashiCorp Vault is another great way to do that. And all of these tools are great because they are built into the cloud and they're very usable. And they reduce the friction that both an operation team and a developer would have in essentially trying to fit their secrets into a configuration file and deploying them to machines and mishandling that and leaking them all over the place. As much as possible, I think it's great to not have to manage secrets at all. 10 years ago, it was a gigantic pain in the butt to have to manage SSL certificates, right? You have to store the private keys for 2, 3 years, 4 years sometimes.
Yeah.
You had to distribute those to machines. It was incredibly hard to do. We built, I don't know how many versions of Puppet modules and Chef modules to do this securely. It was very, very costly to do and maintain, lots of overhead for storing those and having the backups, etc. Nowadays, you just click a button and you get Let's Encrypt certificates deployed directly to your load balancers or to your machines. That's a good example to me that when possible, we should just not manage the secrets at all and use automation to just let the system create the secrets, deploys the secrets, delete them when they're no longer needed, and they never really get in the hands of an operator. Right. Yeah. And that incredibly increased security very quickly. It reduced the burden to operation team and it reduced the risks.
And I guess it's another good example of short-lived certificates are better if the user experience can be like auto-renewal. Getting new certificates is easier than having let's say a 3-year like SSL cert back in the day that would have to get revoked by a CA, and it caused all sorts of other problems.
That's right.
And then in the second chapter of your book, you go into watching for anomalies and protecting services against attacks. I think one of the core areas of this, you look at log management. And I know many startups have very patchy log management when you're getting started. If starting out, do you have any tips for what people should first think about sort of ingesting as far as key logs?
Yeah, log management is absolutely critical for security teams, of course, but pretty much anyone else who's involved with building and running services in the cloud. And that's a problem that an organization would have to solve regardless of having to deal with security issues. My advice is, again, as much as possible, leverage what exists in the cloud infrastructure. If possible, try to not build your own logging pipeline by gluing together a bunch of instances and trying custom configs of rsyslog, et cetera, and instead try to use the capabilities that already exist. I know in GCP, Stackdriver is frankly excellent. You can get your logs into a UX where you can search them and visualize them very easily. You can export them to BigQuery and have a year worth of log that you can query directly from a web interface with some variants of SQL. That is extremely powerful. And it is a lot more powerful than anyone could build inside their environment by hand, right? I mean, trying to run
and maintain it and update it.
And maintain it, right? Yeah. And making sure you don't lose any of those logs and that they rotate properly and all that stuff. I mean, we spent a lot of time, in the 2000s and early 2010s, running security investigation with grep and writing custom scripts to go search through gigs, sometimes terabytes of logs. And it works, right? But once you've tried the logs in a database, in a data lake like BigQuery, and you understand the flexibilities that gives you and the capabilities you get out of it, it's a whole different world. And there's a lot more you can do with those logs. That would be the first, I think, really the first thing that organizations have to focus on is make sure you have a good logging story that you can leverage what's inside of those logs at a reasonable, usability cost.
Starting with, your like application logs, but then also your other event logs that you get from your cloud provider as far as logins and other activity.
Yeah.
From a security perspective, what other things should people be looking out for as far as logs of access that we should keep an eye on?
Yeah, I like that you mentioned the cloud logs themselves, because when we talk about cloud security, we talk about credentials leaking and being misused, really being able to dive into those cloud logs and the audit logs and the access logs of the infrastructure themselves to detect that a certain account has started misbehaving and started creating a bunch of instances when not necessarily expected, is a great way to find essentially abuse and attacks.
It's like the smoke test for the credential leak, like someone's been using it.
That's right. And sometimes the infrastructure provider will tell you, right, that your credentials are being misused, and they will even disable them for you if they notice it early enough, but sometimes they won't. Being able to consume what comes out of the control plane of the infrastructure is very, very important. And those logs are very difficult to read and comprehend as well. So getting exposed to those logs early on and really understanding how to query them and how to manipulate them before there is an attack is important. At the application level, at the service level, I think it's very important to work with developers in defining a reasonable standard for logging. The last thing you want is to have 20 or 30 applications in production, and each of them uses a different format for logging. Now, the format doesn't need to be perfect, but it should have what we used to do at Mozilla, and we had a standard JSON envelope with a standard set of fields. And some of the fields in there were kind of free form, but you knew what to expect from the base envelope, and it made it a lot easier to grab all of the logs that were within the same time window, for example. And that is very important to do. So all of the application logs that are issued by the software should follow the same base format and should go to the same place. And then you can start thinking about what type of advanced threats you want to detect in those logs. And that entirely depends on what the application itself is doing, right? If you're running an account system, you may be interested in detecting password stuffing attacks, or if you're running a shipping and ordering system, you may be interested in catching a spike in orders from a certain geography at a point in time, right? This is the type of stuff that you will essentially have to identify with the developers by doing threat modeling with them, and then build detection for in a more advanced detection pipeline, right? Not really the basics.
Comes down to what are the threats of your business and what are the issues that you need to protect.
That's right.
In this chapter, you also talk about using geographic data to find abuse. Do you have any services in which you'd recommend as far as building systems on top to use geographic data as anomaly detection?
I don't think I have any system to recommend. Every time we've done this or I've seen it done, it was done using custom code. The basic principle is very, very easy to comprehend. If you see a login action from a certain latitude and longitude, and you see another logging action for the same account from a latitude and longitude that is so far away from the first one that it's impossible for that person to have traveled at normal speed, you know something is up. You know that either those credentials are being shared, or they've been stolen, or someone is using a VPN, et cetera, but you know that there's something to investigate here. And we use that a lot. Like most modern sophisticated SSO and identity management system will have this type of detection built in. When you try to log into Facebook and you're on vacation in the Bahamas, you will see a bunch of different little tests that Facebook wants you to run in order to get into your account, right? And the heuristic to trigger that set of tests is most likely location-based. This is a type of more advanced detection that is appropriate for a certain type of system, but you also wouldn't want to have a location-based test on any sort of web service out there, because the cost of triaging those incidents and investigating them may be high. So you want to be very purposeful and specific when you enable those tests.
Yeah. And, as we kind of go through all this sort of log management and capture, you touched on it that people can be sensitive. How do you prioritize what do you alert on as opposed to what you just collect and then use later?
That's always a struggle. There's always a temptation to, particularly in less mature detection system, to alert on everything. To me, the alert, there are two criteria that are very important. One, the alert needs to be of good enough quality that an analyst can take it and do something with it. I remember back years and years ago, we used a host-based intrusion detection system called OSSEC, and it would alert every time there was a file change in /etc.
So there'd be a lot of noise.
Yes, because we had hundreds of servers, and they will do Puppet deployments that will touch all of the files in etc. And all of those alerts will be sent, not aggregated, will send an individual email to my inbox every time that happened. And I would end up, every time someone would do a large deployment across infrastructure, with 20 or 30,000 alerts. This is a pretty clear case of the alert is useless. This is not nobody's. I used to mass delete them and etc. But as as you're building a detection infrastructure, it's important to think about what you're going to do with those alerts. Are they interesting? Are they useful? Can they be investigated? Is it worthwhile to spend 20 or 30 minutes looking through one of those alerts? And the second aspect is trying to prioritize those alerts by type of threat and type of environment. It's possible that an alert is worth investigating, but only on a specific type of system, and not across, for example, the dev or the staging environments, right? Because we know those are kind of more open and etc. So being really mindful about which alerts are being sent to human beings for triage is extremely important, because alert fatigue is a real thing, and people will quit their job if they are constantly flooded with alerts they can't investigate.
Then I guess it comes like the boy who cries wolf. When a real alert
Yes,
comes
exactly.
in, people.
We've seen those even on like large companies going to give a presentation at conferences saying we're seeing 300,000 attacks a minute. I'm like, no, you're seeing 300,000 port scans a minute. These are not attacks. But it's often difficult to explain to leadership the difference between detecting the noise of the internet and the difference between detecting something that may be a threat to the organization.
Yeah.
Right. And that's really where the value of a mature detection team is.
And I think one thing I liked about this chapter is you use lots of Linux primitives, such as like audit D. Do you have any ones that people should use or avoid? We have lots of customers who use SE Linux, and they also find them wanting that control over Linux, but also kind of shooting themselves in the foot for what they need to do.
As a general, very, very general rule, it's always better to prevent than to detect. So SE Linux may allow you to prevent a certain type of attack, and that's better than allowing it and trying to detect it happening. With that said, I personally have a love and hate relationship with SE Linux and these type of systems, because I've seen them get in the way of normal work so often that they end up creating a lot of frustration and actually a lot of friction between the operations team that's trying to run those systems and the security teams that's enforcing the use of this control. So I think it's important to be mindful about the type of control that get deployed and whether they are really worth the cost that they put on the rest of the organization. Audit D is an interesting one because there's a lot you can get out of monitoring syscalls on a Linux box, but it's also incredibly noisy. I think it's possible to have an audit D configuration that is specific enough that the signals you get out of those alerts are valuable, but it's also very, very easy to get completely flooded by an enormous amount of noise and to lose the value of those logs very quickly. To me, the question is, again, like, which systems do you really want to protect with these types of controls? And which audit rules do you want to enable? And be very mindful and specific about that. And always keep an eye on the impact that this has on not only the security team workload, but also the operations team and the performance of those systems and all of this, right? It's take everything into account as you build this out.
So I guess an example would be you would use it for system processing like financial data, but not for your public website.
That's right.
Moving on, in your book, you then go into like detecting intrusions, and you have a great story named The Caribbean Breach, which I enjoyed, that starts off with a mojito and then it goes downhill from there. Can you just quickly walk listeners through this breach scenario?
You know what? It's been so long since I've written it that I'm not sure I remember all the details of it.
I read it yesterday. Well,
yeah, you do it.
Starts off with a company offsite in a Caribbean island. And there's it seems that someone posting on the website is a false statement that is against the company. And so I think maybe they're publicly traded, but I think the stock price goes down, and then it sort of goes through preparation, identification, containment, eradication, recovery, and lessons learned.
That's right.
It's those 5 steps. And I actually love the use of storytelling. Do you use storytelling regularly to sort of describe your sort of job?
Oh, absolutely. Yes. So I this this chapter is probably a chapter I would have written even if I didn't have written the book. I wanted to tell that story of what happens when your organization gets targeted to a point where pretty much everybody is involved. And I really wanted to express how stressful the exercise is, but also how much value you can get out of it. And you simply can't do that by writing technical documentation, right? And this is where storytelling is very powerful. Um, the Caribbean breach is a very fun chapter because it is fictional, but also not really. So a lot of the characters in the chapter have recognized themselves. and
Yeah.
and they asked me afterward, like, is this me? Like, well, part of this character is you, maybe. I don't know. But it's based on my work experience and the type of incident I've worked over the years, and what I've seen succeed, what I've seen fail. um, I have seen exercises done in executive boardrooms where it was completely fictional, and yet within minutes you would have the chief legal and the CTO yelling at each other. Uh, and yet it was a fictional exercise. It was just a situation we're putting them in, and they were already at each other's throat. You can imagine what that situation would have been like if it had been a real incident. I have seen situations that are just mind blowing, post mortem, where people are pointing more interested in pointing fingers than trying to find the actual root cause of the issue. It is very important to take the human aspect into account when responding to incidents, which I think a lot of modern organizations, I mean, certainly Mozilla was fantastic at this, and Google is incredible at it as well. They do really, really well. They understand what good postmortem look like, what good incident management look like, and which phases and you need to follow in order to properly respond, recover from a breach and from an incident. And the Caribbean breach, it's a fun little story, but it's also very typical to how an organization would respond to this type of attack, right? You suddenly you don't trust anything. You have to go investigate every single aspect of the infrastructure. You have to go rebuild a large number of systems. You have to implement last minute mitigations on things. Oftentimes, have to kind of try things that will not work and yet spend a day or two trying to build something you'll have to throw away because it's no longer needed or it's not the right solution. Like, you're scrambling effectively. And the role of a good, mature security team and security leader is to bring some structure and some confidence to that chaotic process. And that's what I was trying to show through that chapter.
A tool you mentioned, which was new to me, was AWS IR, I think instant response, which is used a certain part of the sort of containment to sort of capture the AMI for sort of later inspection. How important do you think it is to sort of keep these compromised images for an organization?
I think it's very important. I think the problem you will face dealing with a major incident is that you don't know, as you're dealing with it, really how bad it's going to get. You think that it may end up being nothing, or it may end up being an incident so bad that it may put the entire organization at risk. While you're waiting for those answers, collecting forensic evidence, even if you end up not using it, I think is very important. It's possible that, in fact, in the majority of cases, you will probably just keep that evidence for a few months and throw it away. But there may be situations where you will hand it over to the FBI because they want to review what they found, or you may hire an external firm to go perform forensics on it for you. So having that data I think, is a critical part of the process.
Do you have any advice if anyone wants to do sort of a game day similar as far as this scenario or other security scenarios?
There are two ways to do it. It's always fun to kind of take a fictional incident and, without even touching the keyboard, just get everybody in a room, physical or virtual room, and thinking through the response process as a group. And very quickly, you'll find things like, oh, I need to access this documentation, but oh, it's on that system and that system is down right now. I can't access it. And it's a very lightweight way to capture important disaster recovery items, right? So you need a backup of this on everybody's machine, so that if the systems are down, they can still access the backups, et cetera, for documentation, right? Not live data, for example. And that's always fun to do. It takes a few hours to prepare, maybe half a day to run through. So not a very expensive process. Beyond that, I think when an organization reaches a point where it has enough technical debt that there are enough attack vectors to be concerned about, it's good to hire an external firm to break into part of that infrastructure and maybe do that a little bit as a red team, blue team exercise, where the firm is a red team and the blue team tries to essentially detect them. So maybe they know the red team is coming, maybe they don't, right? And you just try to treat it as an exercise. You can push that even further and say, we're going to take this system over there and turn it into a mini CTF, right? That team is going to try to attack it and the blue team is going to try to respond. To me, the main point is that this is where a lot of teams will have quite a bit of fun if done well, right? I mean, for better or worse, incident response is extremely engaging, and there is certainly an adrenaline rush that goes with it. And some people enjoy it a lot. Some people find it excruciating, but it can be turned into something that is engaging, right, to the team.
And then moving on from the Caribbean incident to maturing DevOps security, what do you see as top threats in an organization, and how would a team go about figuring this out?
The most important part when trying to identify top threats is to go talk to people. Trying to come up, for example, taking an existing framework, like you take the MITRE attack framework, very good document, right? But trying to apply that to an organization in isolation without talking to anybody will probably be inaccurate. And often the top threats are already known to the executives and the leadership of the company. And it's fairly easy to go ask them or ask a CEO, what are you worried about from a cybersecurity perspective? Or even from a business perspective, right? Are you worried about a competitor breaking into your system to steal, information and data? Are you worried about an employee being malicious? Are you worried about an actor from another country breaking into our systems? Sometimes those fears are justified. Sometimes it's not properly informed, but it's always an interesting data point to know what the executives are thinking about and worried about. I think it's also valuable to go talk to the people who have been around for a while, software engineers, systems engineers, and ask them, where do you think the vulnerabilities are? Where do you think the threats?
They kind of know where the skeletons are hid in the infrastructure.
Exactly. Where do you think the skeletons are hidden? Exactly. It's rarely where you think they are. or they will point you at that big application over there that's very, very well secured, but is completely controlled by that one little cron job that's running on a 10-year-old machine that has full admin permissions to it and that nobody wants to touch. Exactly.
Yeah.
They will know that stuff that nobody else knows about. Within a few weeks, within a few months, you can start building a picture of where the real risks to the organization really are. And that, I think, is very valuable to any sort of security program.
And I think you touch on a few different frameworks. I know you have the Rapid Risk Assessment Program, and there's a few others. For people who don't have one yet, where's kind of a good place to start?
It depends on the size of the organization, I think. For a very small startup, it is very impractical to try to adopt a risk assessment or threat modeling framework, because even the most lightweight ones, and the rapid risk assessment one is one of the most lightweight that exists today, we still require someone to spend a significant amount of time familiarizing themselves and building out the program and etc. And if you have 10, 20 people and maybe one person on staff dedicated to security, you don't have that kind of time. So for a very, very small organization, I think it's better to just ask people around, as you're building out the infrastructure, hey, what are we worried about? What amount of security we want to put here? What amount of risk do we want to take, without really trying to fit that into a framework? when you reach 100, 200 people, and there are 2, 3, 4 people dedicated to security, then it becomes a little more practical to try to implement an existing framework, try to do threat modeling. But I think the way to do that is by still talking to people, going into those design meetings and asking engineers, what kind of threats do you think we're exposed to here? How would you think someone could break into this service? And what amount of security do you think is appropriate to put around it? It usually covers the majority of the threats. Now, you can inform that process with a threat dictionary from one of the many existing framework out there. And ISO 27001 has references and etc. That a security engineer can use. But the part that is really critical is having that culture of discussing threats and discussing risks with the engineering teams. And that really creates this this momentum to think about security without necessarily thinking about cost, right? It's more about, we want to build good things that are secure, that people can rely on, and we're not treating security as a compliance item.
If you're early in those meetings, you can build secure systems as opposed to retrofitting or
That's right.
doing it afterwards. It's much easier to do it from day one than a year later.
Yep, and oftentimes the developers themselves will know how to build something securely, right? I've very rarely met engineers who didn't want to build security into their systems or their services. They often don't necessarily have the support to do so because that security requirement is not well documented, not well explained, not justified, right? And this is where a security team can provide a lot of support to those engineers by explaining to their management chain, yes, we need to spend X number of days on this security feature because of X, Y, and Z, and essentially support the developer's effort.
Yeah, because it's sort of similar to QA. Like, once the feature goes out, it's not just getting the feature out the door, it has to be secure as well as working.
Yep, that's right.
And then for testing security, do you have any tips if people want to start a bug bounty program?
Bug bounty programs are difficult because they're very noisy at first. It is good, again, going back to the point we were discussing at the beginning of this episode, is rely on existing vendors to ramp up your bug bounty program. Don't try to necessarily ramp it up from zero. I think it's also important to clearly identify what is in the scope of that program. Before building a bug bounty program, bug bounty programs are good for low-hanging fruits, right? So if you have an XSS, a SQL injection, some vulnerabilities in the web app, the bug bounty program will likely focus junior researchers against those issues. It's also a good indicator of the health of an application. We used bug bounty metrics to say, well, this service is getting 10 times more reports than that other service. So clearly there's something at play here. Let's go focus an expensive security audit on that service. And we would find a lot of stuff. It's also a good justification for other security efforts. Like, I remember back in the days, we had an application that accepted user input and it would get XSS all the time, constantly. So we used the bug bounty data to justify implementing content security policy in that application. And we again use the bug bounty data to show that essentially we didn't get a single report after implementing that CSP. It was a good metric.
It's a very easy-ish way to fix these issues.
Exactly. And we use that metric then to go talk to other teams and other applications and tell them, you should also implement a CSP. Look what happened to that application when we did. Yeah. So bug bounties are good for that. They are not going to detect sophisticated attacks. They're not going to replace investing into security design, a good security program, or partnering with good security firms to do regular audits, right? They will help with the very basic type of attacks on web applications.
In your past experience at Mozilla, and I don't know if it's the same at Google, but you've worked a lot with remote teams. Do you have any tips for working with remote teams? I know this also, I know we're during COVID now, but this is kind of before COVID.
I think the first one is the quality of your audio and video plays an an immense part in the remote experience. I once had a junior engineer who didn't want to cancel a meeting with me. So he decided to take the meeting while he was waiting at the DMV.
Oh, yeah.
I told him, like, this is great. And I know the topic is urgent, but it's not that urgent. And I definitely don't want to take that meeting from here. There's just too much background noise. So trying to be mindful of your location, your audio, your video helps a lot. The other thing is recognizing that remote teams also need to get together from time to time. You need to build up those connections. You need to, well, now it's not possible because COVID, but when travel reopens again, get together somewhere, have dinner together with your coworkers, spend some time at a whiteboard thinking about engineering, etc. That really helps create cohesion that then supports the remote effort, right?
Yeah.
And then the third point I would make is that being remote is not just about being distant from each other. It's also about having very, very different work schedules. And so adopting an asynchronous first communication style and not expecting people to respond right away or to be there at their desk when you ask them a question is also important. So have more things in writing, send more emails, send messages on chat, but know that you may have to wait a couple of hours to get an answer. All of these things make the remote experience better.
Yeah, I like that. I saw a tweet the other day about the Linux kernel being made over a mailing list.
Yep.
So it's just definitely a reason that, if you can make a kernel over a mailing list, it's proof that everything else is kind of easier.
That's right.
So you published Securing DevOps in 2018. Technology is a fast-changing field. If you were to do a revision now, is there anything that you'd include or leave out?
Yeah, I think I would certainly. So one of the chapter that I'm least comfortable with is the one around really the detection pipeline that I would rewrite and use very different technology today. Like I mentioned, I think I would make heavy use of technologies like Stackdriver and BigQuery because I think they work fantastically well for any sort of anomaly detection and log analysis. The core principles outlined in the book, they have not changed. They're still the same. The technology, the tools have evolved considerably. I started writing Securing DevOps in 2015. Kubernetes was not something we talked about really back then. And while I wouldn't necessarily spend a whole lot of time on Kubernetes in a new edition of Securing DevOps, I think it has its place, probably in replacement of Elastic Beanstalk, for example. So there are things I would adapt. The overall, I think, message is the same. I would have to decide whether to keep or leave out the chapter on TLS, because one wonderful thing that happened over the past decade is that we turned HTTPS into an implementation detail that no one really has to worry about anymore. You just turn it on and it works. And 10 years ago, we wrote scanners to verify cipher suite configurations. We spent an enormous amount of time working with systems team to have their TLS improved. I had conversations after conversations with vendors on supporting better ciphers and helping them support better ciphers. And all of that stuff is pretty much gone now. You just turn on TLS 1.3, you get your certificate from Let's Encrypt, and boom, you're done. Right? There's no battling the protocol anymore. I think that's a great thing. I hope that more and more of the internet infrastructure goes in this direction of secure by default with great usability stories. And hopefully, maybe someday, we won't even need a security team anymore because it's just secure by default.
I can always dream.
Yeah, very unlikely, but hey.
So just to close it out, what piece of advice would you give to a junior team member trying to implement your security best practices?
The first one is know that a book like Securing DevOps outlines a long security program. We're talking 3 to 5 years. It's, I would say, a very experienced security team with good investment and maturity can implement a whole program like that in maybe 3 years. But for a junior engineer joining a startup, trying to build out a security program, know that it's going to take you 5 years. And that's okay. That's okay. Focus on one problem at a time, build and gain trust from your peers, because the worst thing that can happen to a security engineer is to be distrusted by the rest of the engineering team. So trust is very important. Solve problems, think about impact and usability, and communicate a lot, right? It's very tempting, and I still see a lot of engineers that come out of training and schools and universities today, and they focus on the hard fundamental problems of security. They will be great at reverse engineering. They will be fantastic cryptographers. And I try to explain to them that 99% of the problem they're going to have to solve are really along the line of someone left a private key somewhere on a public website.
Yeah.
And there are more, most problems are not technical. They're human problems. They're usability problems. And so you have to be human, and you have to, build trust and communicate. That's very important.
Well, that's a great way to end. Thank you for your time today, Julian.
Thank you so much. This was a lot of fun.
This podcast was created by Teleport. Teleport allows engineers and security professionals to unified access for SSH servers, Kubernetes clusters, web applications, and databases across all environments. To learn more, visit us at goteleport.com.